do number 6 on section 1.4. And on this one, it says, let f be a function with the following properties. It's differentiable at every value of x. And f of minus 2 is 1. So if this is f of x, f of minus 2 is up 1. And that's all we got on that. Now the derivative, so if this is f prime of x, we know that f prime of negative 2 is negative 2. F prime of negative 1 is negative 1. F prime of 0 is 0. And then 1 and 2. So f prime of x is equal to x. It looks like. It might do strange things in between, but in general, the pattern is y equals x. Okay? Now we're supposed to sketch a process, but we're supposed to do f of x. Well, a line comes from a parabola. And the slope of the parabola at 0 is 0. So that's got to be the lowest spot. So the axis of symmetry has to be the y-axis, because it's the same this side and this side. And so it's got to be the same here as over here. So at plus 2, it's got to be 1. And the lowest place is still in question. Now they say the slope at negative 1 is negative 1. So that's sloping down like this, and somewhere in here it's got to be sloping down like this. Now, I'm not sure where. I'm just going to put it right there and say it's a slope of negative 1. So I'm going to come like this. And at the slope at 0 is 0, so it's got to go flat, and then it's got to be plus 1, and because it said plus 1 at 1, and then slope of 2 here. So that's my rough sketch. So I'm saying it's y equals maybe x squared or something times x squared, and down some. Now, I'm not sure how much down. Let's see. If this were the derivative, we know that the derivative of x squared, if we have x squared from previous problems, so we found that the prime would be 2x, but this is only x. So this is half as steep as a normal parabola. So this parabola must be squished so the steepness gets decreased, probably by a half. Now, if I put in minus 2 squared is 4, half of 4 is 2. But we're only at 1. So this parabola must be moved down 1. So this should go through there. Well, I was close to there. And now we have a better idea of where this parabola is. There's an estimate for the equation. Using a graphing utility, graph both this one and G prime. Does your formula of G prime generate the graph you expect? Yes. Use the limit definition of the derivative to calculate the derivative for p prime of x at 5x squared minus 4x plus 12. Well, there's shortcuts to that, but we will do, oh, wait a minute. That's 7. What am I doing here? 6. Conjecture a formula for f of x. We did that. Use the limit definition to derive f of x. So we could use the limit definition on that. That's what they want us to do. So we'd have the limit as h approaches 0, and we have here 1/2 a plus h squared minus 1 minus 1/2 a squared minus 1 over h. So I get the limit as h approaches 0 of a squared plus 2ah plus h squared times all times a half minus 1 minus 1/2 a squared plus 1. Those cancel. And some more is going to cancel here. That's all over h. So I get the limit as h approaches 0 of 1/2 a squared plus half of 2ah's is 1ah plus 1/2 h squared minus 1/2 a squared. And these both have h in it, so I'll be able to do something with that. So it's going to be the limit as h approaches 0 of ah plus 1/2 h squared over h. This h will cancel one of the h's, and that so I get and as h goes to 0, this will be a, and that will be 0, so I get a. And then if we go back and say, okay, we want f prime of x at any x, at any a, this would be x. And that matches what this graph said.